Okay, this is the 2017 AP Calculus official practice exam. In this video, I'm going to cover number 3. And I'm not going to draw on the whiteboard the graph. I'll just pull the paper onto underneath the camera as I need to. But this is a graph of function f. Okay, so you can see it's below the x-axis until you get to 1, and then it's above the x-axis. And we're going to need to use the shapes in this graph to answer some of the questions. So you've got a triangle here, and then a semicircle here, another triangle here, and then a triangle above the x-axis, and finally a rectangle if you were to divide it all up. And the graph says, the problem says that g of x is equal to 1 of x of f of t dt. So what that means, remember, if you take the derivative of g of x, g prime of x, you plug the upper limit in. So g prime of x is equal to f of x dx. So what that means is this graph of f is also a graph of g prime. So f is just equal to g prime. So that'll help us answer some questions about the function g. So for this particular problem, all 4 parts, the only really hard part is part A. All right, one of those where you get the tough one first. And so you want to, if this happens on the 2020 test, you want to read through all the parts, and maybe you need to answer questions B, C, and D and then come back to A. But what it says is find the average rate of change from x equals -5 to x equals 5. Well, the average rate of change is equal to the slope of the secant line. Now, if they had given us a graph of g and not a graph of g prime, that would be super easy to find. But instead, they gave us the graph of g prime, so we're going to have to use the fundamental theorem of calculus to get this. So that secant slope is going to be from -5 to 5. It's going to be g of 5 minus g of -5. So that's y2 minus y1 over 5 minus -5. Well, g of 5, you can't read the graph to figure that out. It's not just look at the graph and plug it in. To get g of 5, we have to use the fundamental theorem of calculus. It's going to be from 1 to 5, so we plug in that upper limit for x, okay, we're putting that 5 right there, of f of x dx, and from 1 to 5, we're going to figure out the area under the curve from 1 to 5. So from 1 to 3, we have a triangle. Okay, see that right there? So it's going to be 1/2 base. The base of that triangle will be 2, and then the height is 4. That's from 1 to 3. And then from 3 to 5, it's a rectangle. So it's just a base of 2 and a height of 4. All right, so that's going to be 4 plus 8, which is 12. All right, so this part was from 3 to 5. So g of 5 is 12. That's not so hard to figure out. But now we got to figure out g of -5, and it's easy to mess things up here. Because from on the negative side of the graph, it's below the axis. Okay, so g of -5 is from 1 to -5 of f of x dx. Well, what do you have to do there? We know we have to have the smaller number be the lower limit. Okay, so we have to flip those end points. So we would have we need 1 on top, the larger number on top, and -5 on the bottom. Okay, and you can do that by putting a negative out front, and that's where we have to be careful on this one. Okay, so let's look at the areas. So from -5 to -2, we've got a triangle, 1/2 times 3 times 4. But since it's below the x-axis, and we've got this negative out front, so -1/2 times 3 times 4. So that is from -5 to -2. All right, and then how about we've got another shape from -2 to 0, we've got a quarter circle. All right, so that's going to be 1/4, but it's going to be negative because it's below the x-axis, so sorry about that, minus 1/4 pi, the radius is 2, 1/4 pi r squared. So that's from -2 to 0. And then from 0 to 1, so all of this is below the x-axis. From 0 to 1, we've got another triangle. The base is 1, the height is 2. So, but since it's below the x-axis, it's negative, so 1/2, base of 1, height of 2. So what a mess. All right, so that's going to be -6, and then minus pi, okay, 4 and 1/4 cancel, and then minus 1. So that's going to be -7 minus pi, which is going to just be, if you, 7, let's see, what would that be? 7 plus pi. So g of -5 is equal to 7 plus pi. So to get the secant slope, now we can plug the numbers in. 12 minus 7 plus pi over 10. 5 minus -5 is 10. So that's going to be 5 minus pi, right? Minus plus over 10. Wow. Now you learn a lot in this problem. I don't think they will give you one this convoluted on the 2020 test, but they could give you something that utilizes some of this, so this is a really good problem to take notes on and to study, I think. But the rest of this problem is far easier than this one. Okay, so pause the video if you need to while I erase this. All right, part B says find the instantaneous rate of change of g with respect to x at x equals 3, or state that it does not exist. All right, this one is so great compared to part A. So you know that the instantaneous rate is equal to the slope of the tangent line. All right, slope of the tangent line. Well, at x equals 3, slope of the tangent line would be g prime of 3. Well, g prime is just f. So let's just read the graph. What is f of 3, or g prime of 3? 1, 2, 3. It's 4. Boom. That one is just to read the graph, whereas the last one was, oh my goodness. Okay, part C says, on what open intervals, if any, is the graph of g concave up? And justify your answer. Okay, let's look. So we're looking at where is the thing concave up. All right, so I'm going to put this over to the side here. I hope you can see that graph. Look at your own paper there. So G is concave up, and remember on the test they're going to want explanations. Where G double prime is greater than 0. Well, what is G double prime? Well, that just means the slope of g prime is greater than 0. Remember, the second derivative is just the slope of the first derivative. So if the slope of g prime is positive, then you know g double prime will be positive, and therefore that's concave up. So let's take a look at the graph. Where is the slope positive? Well, it's positive from -5 to -2, right? The slope is positive. And then it's positive from 0 to 3. Okay, so where is it concave up? You can just write this as an interval from -5 to -2, and then from 0 to 3. So where the graph goes flat, that's not part of the interval, okay? The slope's got to be increasing. All right, so that part, not too bad. Okay, let's see if I can fit part D on this whiteboard here. Okay, so it says find all x values where g has a critical point. So remember, that's not going to be hard because where do the critical points occur? It's where g prime, which this is a graph of g prime, not just f, but g prime. It's where g prime is equal to 0. Well, where does g prime equal to 0? Well, it's at -2 and it's at 1. So those are your two critical points. So a critical point occurs where g prime is equal to 0. So that occurs at x is equal to -2 and then again at 1. Okay, so at that critical point, do we have at those two critical points, do we have a minimum, a maximum, or neither? Okay, well, at x equals -2, see how the graph stays below the x-axis on either side? So it would be kind of, if we were doing a sine line, like we did in class, and we were looking at these -2 here, to be minus, 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 minus. And then at our other critical point at 1, it goes above the x-axis. So we don't have a minimum or a maximum at -2, but we do have a minimum at 1. So at x equals -2, no max or min. And this sine line would probably be an adequate explanation, because you could say because g prime less than 0 on both sides. I'm sorry, I'm getting really messy here. I apologize. All right. So for x equals 1, we have a minimum, because g prime goes from negative to positive. Okay, on your sine line here, negative to positive. So we have a min at 1. Okay, that is a great problem. Part A is maybe a little harder than what you might get, but I can absolutely see you getting part B, C, and D. You'll notice every single practice test we do seems to force you to look at the graph of a derivative. Okay, so I think it's highly likely, or certainly within the realm of possibility, that you're going to get that kind of question on the 2020 test. I could especially see it being true on the second question, where you only have 15 minutes, where they might ask you 3 questions like this, and you would have to write an explanation, and if you know what you're doing, you can finish it really quickly, and if you don't, you're toast. All right, so that does it for problem number 3, and I'll talk to you next problem.